false, you follow the other path. Are we doing okay so far? In this case, for a if construct, there is something to do or something optional they can specify to do when the condition is true. Then you move on to whatever is next. If the condition is false, on the other hand, there's absolutely nothing to do. And then these two paths will merge and continue on to whatever is next. Are we doing okay so far with this logic? We are basically mapping this little construct in Scratch to a trail map that represents that logic. So it seems like in this particular case, what we want to do is to say, if the sprite is on edge, I want it to increment the bounce counter by 1. Is that making any sense? Okay? Because if it is not on an edge, it is just in between the edges, I don't want to do anything with the bounce counter. I don't want to increment it when it is not touching the edge. Okay? So let's go ahead and see if we can do this one right. Okay, the first time we do it, I can guarantee you it is not right. It seems right, but it is not. So what we need to do now is to go to the Sensing tab because it has the touching. Okay? The touching block is a hexagon, which means it will fit very nicely into the hexagon of a if construct. And what we want to do is to put the change bounce counter by 1 into this block here. That is easier said than done because when you drag it, it will also drag the weight out. So now you have to separate these two, put the weight back into the loop, and then put the other one into the conditional statement. And of course we have to specify if touching what, okay? There's only two options here, either the mouse pointer or the edge. So in this case, we select the edge. And then we put this entire block, we drag it back into the loop here, and now we have a slightly updated logic, which seems that it should be doing the right thing. But I can tell you that it does not do the right thing because it will still increment bounce counter more frequently than it should. Okay, so let's go ahead and run the program. And then we'll see why I say that it will increment the bounce counter still way too often. Okay, so we can see that it remained at 0, and it does not even increment. Is that because it bounced too early? Okay. If that's the case, we put the bounce after the conditional statement. That. Okay, so now it's working just perfectly. Because I have to reverse the operation, when the bounce would actually make it not touch the boundary again, or not touch the edge anymore. So that's why if I have the if on edge bounce before the conditional statement, the condition of the conditional statement will never be true because the bounce action will make the sprite not touch the edge anymore. That's why the order of operation is important. Are there any questions at this point? No questions? Okay. Now, if I let this program run, it will just keep incrementing the bounce counter forever, which is, kind of interesting, but that's not what I wanted to do. I wanted to bounce maybe 3 or 4 times, and then I want to either stop the program or continue with something else that I want to do. So let's go ahead and stop the program and ask ourselves, what do I have to do to basically say, I will keep doing this until the bounce counter is 4?
You want a forever condition. So you want a forever if a certain
Okay,
condition.
that's a good starting point. Let me change. It's already on 1, 2 in the front. I'm just looking at the contrast of the screen. It's kind of washed out at this point. Okay.
Don't you want to repeat until instead of a forever if?
Aha. Yep. But let's go ahead and use a forever if and see what it does. Okay, because it seems like it should do what we want it to do. Okay, let's go ahead and take both blocks out, and then we can take a look at both of these blocks, and then we can compare and say, are they really the same thing, or are they not the same thing? The first one is a forever block or forever if block. The second one is a repeat until block. Okay, they look very similar. Okay, you look at the first one, it has a hexagon slot here so that we can specify a true-false condition. The second one also has a hexagon here to specify a true-false condition. Both, can include something in between. Both has a little arrow to go back up to indicate that when the condition is, in this case, if the condition is false, we'll do one iteration. But at the end of the iteration, we go back and try to ask, do we have to do it again? And if the answer is yes, we have to do it again, then we'll perform another iteration. What is visually different is the little tab here. Repeat until has a little tab here. Forever if does not have a tab like that. Okay, what does that mean? Yep.
That when you use the forever, it will stop if the condition is false. And if you use the repeat until, if the condition is false, then it'll go on to the next step.
It's actually when the condition is true for the repeat until, it will continue with the next step, because the until condition specifies that the condition is an exit condition. When the condition is true, we get out of the loop. Okay. So that's why we want to use a repeat until instead of a forever if, because I might have additional things that I want to do after this loop here. Okay. So let's take a look at the picture of the repeat until loop, because we want to see what it looks like in terms of a trail map, because we are about to use this one here. A repeat until in this case is what we call a pre-checking loop. In other words, it first checks whether the condition is true or not. If the condition is true to begin with, it will skip whatever is specified in between. Okay? So that means that we have a picture that looks like this. Okay? We have a branch at the early on. There's a question here. If the answer to the question is true, we get out of the loop. Okay? Is that okay? Okay, because the condition that you specify with repeat until is an exit condition. It's kind of like when you tell someone, or when you tell a kid, do your homework until it is done. Okay, so the kid will have to keep doing the homework until it is done. Okay, so having the homework done is quote unquote an exit condition. The kid can now move on to watch TV, play a video game, go out to bike and something. Okay. What if the condition is false? What if the answer to this question is false? Then we have to perform whatever action is specified in the loop. Okay? Which is a block of code, can be long, can be short, doesn't matter. What happens after this? What happens after I perform one iteration? Yep.
It goes back to the question.
It has to go back and ask the question again. So that means we have to change the picture a little bit, because now this path leads all the way back to the beginning. We have to open this up and indicate the direction, because in this case it is important to realize that you can only come in through this branch and you cannot get out through that branch. Okay? So in terms of a pictorial representation of the repeat until loop in Scratch, this is the picture. Are we doing okay with this picture? Okay. In our logic, if I just want to say, okay, I will make Scratch bounce 4 times, then I wanted to get out. How do I make use of the repeat until construct? What is the condition? What should I be specifying here? Yep.
The number of counts on the bounce counter.
Bounce counter. I know bounce counter is going to be a part of the question. But what do I want to use? I want to compare that to 4. Okay, I know that we wanted to bounce only 4 times. The question is, what do I use to compare this? Okay, should I use less than, equal to, greater than, or what?
Equal to.
Okay, if I put an equal to, then it will read repeat until bounce counter equals 4. Yep, it sounds about right. Okay, so let's go ahead and specify that in this code here. You can see this is a a hexagon, which means we need something that will return a true or false value. Anything that gives you a true false value is also called a Boolean value. Boolean spells B-O-O-L-E-A-N. Can anyone guess why we have that strange word to describe anything that is either true or false?
Name of a person.
It's the name of Boole, B-O-O-L-E. Okay? And he is the guy who invented Boolean logic or Boolean algebra. As it turns out, with Boolean values, it has its own system, it has its own algebra to deal with equations. Okay? So in this class, we won't get too much into Boolean algebra. We'll just say that, it's a Boolean value because it returns either true or false. Okay? Just like a numeric expression will give you a number. And we know this is a comparison. And a comparison is an operator. So we have to look at the green tab here. We look for the equality here. We stick the equality into the condition. And then we have to specify what are we comparing to what. Well, we know one is easy. One is just, the constant 4. The other one is a variable. So we have to go back to the variable tab, select, drag bounce counter to the other side of the comparison. Okay? In other words, you don't have to type much. The only thing I had to type was for the number, the constant. The other part, they're all based on drag and drop, which basically limits the chances of making syntax mistakes. Okay? You can still make syntax mistakes, but not nearly as easily as a real programming language. Yep, go ahead.
What is debouncing?
Debouncing? That's a good question. Let me finish this first, and then I'll explain what is debouncing. Okay. So what I need to do next is to put this entire block of code out of the forever, because we want to get rid of the forever at some point, and drag this into the repeat until. Now this is also important because now we have 3 places where we can drop this block of code. We can drop it before the repeat until, we can drop it into the repeat until, we can also drop it after the repeat until. We want it to be inside the repeat until because that's the operation that we want to specify inside here. Okay? Are we doing okay so far with the logic of a loop, a repeat until loop in this case? So now we can get rid of the forever. If you want to toss something away, you just drag it to the other side. It doesn't even have to be the right color tab. If you drag something from the program into the tool tab, it would just disappear. That's basically tossing it away. So now we can put the repeat until block right after the set bounce counter to 0 block, and that should do most of the things that we wanted to do. So we want to go to control again, this time to specify the end of the program. So we can say stop script at the very end, so the program will stop executing on its own. And now we can test the program again. The bounce counter gets incremented by 1. I should have specified a smaller delay so it will take less time to run it. But this is fine. We can just take a little break, and it should stop now. And there we go. I know the program has stopped not only because the sprite has stopped moving, but also you can see the block of code here is no longer highlighted. There's no halo around it anymore. Is that making any sense so far? Okay. Are we doing okay so far? Sort of? Okay. Now remember last time I showed you something about the costume thing? So if I want the sprite here to appear to be walking with the animation, I can do that here. In other words, instead of making 10 steps forward, I make it go 5 steps forward. But I would also go to looks and include costume code. So